we're going to see how to rewrite the integral as a Riemann summation. So first, remember that the integral is the sum of all the rectangles when we are trying to find the area under the curve. So the integral from a to b, let's say of f of x dx, this represents the area, let's say, under this curve from a to b. The area is the area of each rectangle, and then we add. So the area of this rectangle is dx times the height being f of x. Now f of x is actually, if we want to put it in Riemann summation, remember that in order to find from here the Riemann summation, we need to find delta x, x sub I, and f of x sub I, because this in some way is going to be equal to the limit as n approaches infinity of, if we're talking about the right Riemann sum, will be summation from I equals 1 to n of f of x sub I times delta x. This, remember, is the same as the limit as n approaches infinity of the summation from I equals 1 to n of f of what's x sub I. X sub I is a plus, a is this, plus the interval delta x times I, and then times delta x. This is the traditional way for the right Riemann sum, and the non-traditional way for the right Riemann sum will be here, the limit as n approaches infinity of, let me put it here, limit as n approaches infinity of summation from I equals 0 to n minus 1 of f of x sub I plus 1, because we are down here, we need to up here delta x. So this is the limit as n approaches infinity of summation from I equals 0 to n minus 1 of what's x sub I plus 1. If this is x, f of x sub I, f of x sub I plus 1 will be f of a plus delta x times I plus 1, and all these times delta x. This is the right Riemann sum. So let's write these integrals in the right Riemann summation, and next we will do it for the left Riemann summation. So this one, the first step is to know what's delta x. So delta x is from a to b, is the interval between a and b. So delta x delta x is the width of each rectangle. So will be b minus a divided by the rectangles. The rectangles are n if we have n rectangles, and we are trying to do this when n approaches infinity. So here we are going from 0 to pi, and we have n rectangles. So this will be the limit as n approaches infinity of summation from I equals, we are doing the right Riemann sum, and this is the traditional way, from I equals 1 to n of f of, f is cosine x. Now what's x sub I? X sub I is a plus delta x. A is, we are beginning from 0, so nothing. And delta x is b minus a over n, so pi minus 0 over n. So pi over n I. And then everything this times delta x, that is pi over n. So this is this one. The other way is in the non-traditional way. That would be limit as n approaches infinity of summation from I equals 0 to n minus 1 of cosine of pi over n times I plus 1, and all these times delta x, that is pi over n. Now this one, the second one will be, let me erase now everything. So the second one is, now our delta x is from 2 to 7, 7 minus 2 divided by n is 5 over n. our a, we are beginning from 2. A is equal to 2. So x sub I will be 2 plus 5 over n times I in the traditional way. So we have f of the limit as n approaches infinity of summation from I equals 1 to n of our function is natural log of x sub I was a, that is 2, plus delta x times I. Delta x is 5 over n I times delta x, that is 5 over n. The other way would be the limit as n approaches infinity from a summation from I equals 0 to n minus 1 of natural log of 2 plus I times 5 over n plus 1. Sorry, let me put it here. Limit as n approaches infinity of summation from I equals 0 to n minus 1 of the natural logarithm of 2, this is a, plus the things that we are doing to the right, because this is getting down, so we need to add, would be here in the I. We are not just considering I, so it's I plus 1. So it's 5 over n times I plus 1. And then all times 5 over n. This was the second one. Now the third one is, again, our delta x. Delta x is 3 over n. X sub I is 3 over ni, because here is just 0. So our f of x will be e to the 3ni, 3 over ni. So is the limit, actually, well, yes, the limit as n approaches infinity of summation from I equals 0 to n, I equals 1 to n of e to the 3 over n I times 3 over n, or the limit as n approaches infinity of summation from I equals 0 to n minus 1 of e to the 3 over n times I plus 1 times 3 over n. The fourth one would be delta x is, again, just 5 over n. Our a is 0, and so our x sub a would be 5 over n times I. So we have the limit as n approaches infinity of the summation from I equals 0, 1 to n of f of x sub I will be x sub I is 5 over n I plus 1. This plus 1 comes from the f. Now, this is the limit as n approaches infinity of summation from I equals 0 to n minus 1 of 5 over n times, here instead of putting I, we will put I plus 1 because we're down here. So I plus 1, all plus 1, and then everything times delta x. Oops, here I forgot to multiply by delta x. That is 5 over n. 5 over n. And the last one is this. Here our delta x is 5 over n. Our a is 0. Here 0. So x sub I will be 5 over ni. But as you can see, our f of x is just 4. So it doesn't depend on I, on x, anything. So this is just the limit as n approaches infinity of summation from I equals 1 to n of 4. 4, and there is anything. 4, that is our f of x, is 4, times delta x. Our delta x is 5 over n. 5 over n. And this is just, this will be just 20 because because this doesn't depend on I, so it's just 4 times 5 is 20. And if you want, you can verify this. If you take the integral, the integral is 4x plus c, and this goes from 0 to 5, so this is 20 minus 0, this is 20, exactly the same that we have. Now in the next video we're going to do this, but now with left Riemann summation.